think this goes between chapter 9 and chapter 10. It's a little interlude to get us ready for chapter 11-10. So we start off with a polynomial of degree n, and I ask what is f of 0. So all these terms zero out and you're left with a naught. Okay? So now the question is, what about the first derivative? Well, the first derivative, what happens? So take a derivative, that term drops out. These guys are all going to zero out when you put 0 in. So what's the derivative of this piece? Well, it's a1. Alright, so that's just going to be a1. Well, what happens next? Take two derivatives. The first two terms go away. Then you're going to get 2a2, right? What about three derivatives? So after three derivatives, this term goes away, and then you'll have to take three derivatives. So the first derivative looks like this. The second derivative looks like that. And then the third derivative looks like this. Okay, we just have this pattern. What happens? Well, each time you take a derivative, another one of these terms disappears. You only keep one piece because the rest of them you're subbing in 0 for x. So it's actually going to be n factorial a sub n. That is the pattern. So next question. You wish to approximate f of x with a line. What line do you use? Well, that's easy. Why? Because right here, a naught is the y-intercept. And right here, or that is, you have the point 0, comma a naught is a point on the line. And then the slope of the line is a1. So that's really easy. So how will you approximate f of x with a line? You just say y equals a naught plus a1 x. Or generically, what if you wish to approximate any function? Let's say you wish, we've already used f, so I'm going to use a different letter. You wish to approximate g of x with a line and you want to match the point and slope at x equals 0. Well, that's easy. G of x is approximately g at 0 plus g prime at 0 times x. Okay, so this is your starting point right here. Start here, and this guy is your slope. Alright, so here's a question. What if we want to approximate? Try this again. You wish to approximate f of x again with a cubic. Centered at 0. Okay, so what was f? We know f is right there. Okay, so we keep using this, so I'm going to take it with me. How's that? I'm going to just steal it. Blink. Alright, there we go. Now, the cubic is going to look like this. You must be thinking, this is way too easy. She can't be doing this. Well, I actually am. It really is that easy. So why is that what we're doing? Why can we get rid of all those big, important looking terms out here? Well, the important thing is, if x is small, then x squared, x cubed, x to the fourth. All those guys are increasingly small, right? And they're getting smaller and smaller. So they're less important. So this term is most important. Okay, and then the next most important term is a1x, etc. Okay, so the order of importance is you start with a naught and you move your way down. Okay? So now what? All right, estimate g of x, so some arbitrary function with a cubic at x equals 0. Well, that should be easy. What did we just do? We just did this guy. We just said this. But wait a minute. Hold on a second. We just said this was true, right? We just said the nth derivative of f evaluated at 0 is n factorial times a sub n. So what does this mean? Well, then you reverse this process. Okay, so let's go back. Hold on. Okay, so if we want to solve for the coefficients, then why don't we just divide both sides by n factorial, and that will tell us what the coefficient is. Okay, so let's go back and just say, okay, so what does this mean? This is just f at 0. This could be f prime of 0. This is f double prime of 0 over 2. This is f triple prime of 0 over 6. So we can just generically say g of x is approximately g of 0 plus g prime of 0 times x plus g double prime of 0, x squared over 2, plus g triple prime of 0, x cubed over 6, which is 3 factorial. Well, I said cubic, so I don't need any more terms. That was what we wanted. Okay? Well, what if we want more terms? Estimate g of x with a polynomial of degree n at x equals 0. Well, g of x is approximately equal to, I need some other index because I'm going to end at degree n, so k is equal to 0 to n. And I'm going to take the kth derivative, evaluated at 0, and then I'm going to say x to the power of k over k factorial. That makes sense. That's just what we've been doing. We just said, for example, 3 derivatives, power of 3, 3 factorial. It's the same structure right there. Okay? So, yep, that's your interlude. And that's the end of 11.9 and a half.